Yes. Uh, Now the topic is optoelectronic and devices. In this session, I'm going to give a little introduction about the optoelectronics. So with that optoelectronic concepts, we can design the devices. This is the basic introduction about the subject. But today we will see the basics of opto. What is by opto and why it has arrived, evolved, everything we will see today. First introduction. Before entering into the subject, we have to understand what is meant by light. So we can define the light in various forms. First thing, saffron sunrise. So this is the saffron color sunrise. This explicit different color of light. Next one, rainbow. The rainbow having 8 colors. All the 8 colors explicit in the form of light, but in different colors. The blue sky also having the light, so that only we can visible the sky blue. It's our treasures to visit the vision the blue sky. So it is having some kind of light scattering. That's why we can able to see the lights behind the screen of blue sky. Next one, red sunset. So these are the different light scatters. So by this we can explain the meaning of light. Next one, what is by optics? It's nothing but a study of behavior of the light. Scattering or mediums can be called as optics. Now, the applications of optics can be started with the manufacture of mirrors, lenses, prisms. This lenses leads to develop a camera, also a video camera, etc. These are the different applications of optics. We already discussed optics is nothing but study of behavior of the light. And in olden days, where we had convention type communications by means of RF, radio frequency, and microwave. But those communications methods have limited capacity to carry the messages. This can be overcome by low glass fiber cables. In that, we are transmitting the messages in terms of laser lights. Also, the modern technologies employs photons to round optic circuits. Next, nature of light. Light is also a form of energy that stimulates our vision. That's why we are seeing that one. In general, energy can be transported in space by two ways. Either by actual motion of matter. Example, if you are dragging a bench over the floor, that is a type of energy is transferring from one medium to another medium. Another one is by a wave disturbance. The light consists of a stream of tiny particles. Here we are saying the tiny particles of light, also called as corpuscles. This corpuscles is a term. It's also available in the medical term. It's nothing but red cells, minute tiny particles, maybe red cells or white cells. Here we are mentioning the minute tiny particles of light stream, which are emitted by the light source. Now, the wave theory of light can explain the propagation of light, the phenomenon of interference, diffraction, also the polarization effect. But it doesn't. Maxwell's theory and other theories failed to explain the emission and absorption of light. That can be postulated by later Niels Bohr. So here, in this first unit, we have to study the basic introduction of light, wave nature, and what are the characteristics of light. By that, we can go choose a different applications for our communication. Now, according to the quantum theory, light is emitted in the form of photons, which are bundles of electromagnetic radiation that oscillate with a definite frequency and propagate through space with the speed of light. So this theory we can see in the next slide video. So this is a continuous straight. When it is applied at the prisms, we can able to see the sinusoidal waveforms, electromagnetic waveforms, and it explicit the different number of colors. So here we can explain the reflection, refraction, every concepts we can explain. But here you can analyze the light scatters. Right. So here we can see when the light is perpendicular to the prism. That's why we are getting the sinusoidal waveform. So with this concept, we are explaining the light waves are in transverse in nature. Transverse is nothing but perpendicular, right angle or perpendicular. If we are up, the lights are emitting from the light source. Lights are emitting from the light source. We are keeping the light in the 0 degree, but the light waves can be propagated in 90 degree to your light source. That is the transverse waveform. Let us see some examples for analyzing the transverse way of light. When a pebble is dropped into the still water in the sense water is in rest. There is no motion in the water of pond or well. That when we drop the pebble into the pond or well, the pebble generates ripples which expands in the form of circles all over the well or pond. If a leaf also floats in the well, the leaf also tends to move up and down but does not travel outward with the wave. So by that we can identify the motion with the help of crest and troughs traveling away from the center of the disturbance. Crest is nothing but in a sine waveform we are having point eruption. And let us consider a sinusoidal waveform. Here this positive cycle may be called as crest and negative cycle can be called as troughs. So based on the leaf floats in the pond, we can identify the wave motion with the help of crest and troughs traveling away from the center of disturbance. There, every particle of water medium oscillates, so the leaf at right angles to the direction of wave propagation. Such wave motion is known as transverse wave motion. For example, electromagnetic waves and water waves. Next, wave nature of light. Light is also an electromagnetic wave or also can be called as transverse wave. EM waves are those waves in which there are sinusoidal variation of electric and magnetic field at right angles to each other as well as to the direction of propagation of wave. Here we can see, here we have mentioned the yellow color signal is nothing but electric field signal and violet color signal describes the magnetic field signal. Both are in transverse in nature. With the help of this concept, we are transferring the message from one end to another through optic fiber communication. Next, wavelength. So let us consider these are the transverse wave signals, and this is having low frequency. This is having higher frequency when compared with the previous A signal, and this is the signal having more frequency when compared to these two signals. So we will study the wavelength. Wavelength is nothing but distance per cycle. So cycle is nothing but a cycle consists of both positive and negative. So this is a cycle. Next cycle starts at here. So the distance between the two cycles or distance per cycle is nothing but a lambda. For example, for a cycle A, the lambda is nothing but just lambda A. For the same time period, the wavelength of B signal is having 2 times of lambda B. We can propagate, right? So here for this 2 time period, here we are having 2 cycles. That's why the lambda of the B signal is nothing but 2 times of lambda B or 2 times of lambda A, right? Next, the wavelength of signal C for the same time period, here we are having 4 cycles. That's why the wavelength of the signal C by comparing with the signal A, we are denoting 4 times of lambda A is nothing but lambda C, right? So wavelength and frequency. So wavelength is nothing but lambda and frequency is nothing but number of cycles per second. Right. That's all. Thank you.